There's a Swedish scientist named Svante Arrhenius. And this guy is most well known as being a father of a field of physical chemistry. But in 1895, this scientist discovered the greenhouse effect. So the notion that heat-absorbing gases emitted into the atmosphere would have a warming effect at the surface. And what's interesting to us and relevant to us here about this guy is at the time he suggested that human emissions from CO2 would be beneficial first in preventing the next ice age, and in fact essential in helping us to feed a growing population. So in the last 100 years, times have changed. As we heard this morning, the effects of agriculture, the estimated effects of climate change on agriculture are said to be negative. The IPCC report most recently released said that the negative impacts of climate change on crop yields far outweigh the positive impacts. The National Climate Assessment report that was released recently, that again we heard about this morning, said that delivered the main message with respect to agriculture, that things have gotten much worse over the last 40 years and are expected to get even worse in the next 25 years. And as we know and as we've heard, the dimensions of these effects are broad. Some of it is temperature, so very high temperatures have detrimental effects on crop yields. Beyond that, it's not just the level of temperatures. Warm nights can lower grain yields if the warm nights happen during the grain filling period. I know I don't sleep well when it's hot at night, and the same may be true for animals, reducing dairy yields and others. Warm nights and lack of chilling may have large effects on perennial crops. There are a lot of scientists who say that, in fact, that the soil moisture effects of climate change might be much greater than the temperature effects. So to the extent that we have lower soil moisture, we may see lower agricultural production coming from that. The National Climate Assessment report that was released recently included work from some UC Davis researchers who had modeled large reductions in yields in many large crops in the next 75 years in California, 10 to 20% reductions in wheat, sunflower, corn, cotton yields over that period. So we're looking at a dire picture. And in fact, I should also say it's more than just temperature and precipitation. A lot of people focus on increased pest prevalence and disease, which affect both livestock and crops. And so with that, and with extreme precipitation, potential effects on soil erosion, we heard about the snowpack this morning, a very kind of dire picture that we see coming out of many of these major reports and many of the writings on climate change. And often, many of these writings don't fully address the potential for the state, for the world, for agriculture and the rest of the economy to evolve and adapt to climate change. So what we're going to talk about in this session is the extent to which adaptation may mitigate the effects of climate change and how that process might come about. So I have three experts here who are going to speak on that topic. And each one will speak for about 10 minutes, just as in the pre-lunch session, and then we'll have plenty of time for question and answer period. So our first expert is Alan Olmstead, a distinguished research professor of economics at UC Davis. Alan's written extensively on adaptability of agriculture to large climatic changes, has notable work on wheat in other areas. A recent book called Creating Abundance, I should say, on technological advance in American agriculture. And Alan also currently serves on the board of directors of the National Bureau of Economic Research, past president of the Economic History Association, and recipient of numerous research awards. So, Alan, take it away.
I see that I got a much longer introduction than the governor.
Yeah.
Thank you, Aaron. I also want to thank the Giannini Foundation and its director, Colin Carter. The point I think that needs emphasizing is I think Colin wanted a historian on the panel to give some perspective, and he was probably mindful of George Santayana's old adage, something to the effect that those who don't study history are doomed to repeat it. I would just remind Colin of my corollary to that adage, and that is those who do study history are also doomed to repeat it. That said, looking at, if I were to describe one aspect of California agriculture today, and looking at it, I would say, you know, the farmers with considerable aid from scientists and agri-industry made, or largely made, their environment. The things you take for granted today, the dams, the 1,000 miles or so of major levee works, the flattening of the lands, the very crops that you grow and the location that agriculturists grow them on, all of this had to be created. And it wasn't at all certain ahead of time where to grow these crops or what to do. The most famous viticulturist, at least in the history of California, is probably Agustin Harasti, who failed to grow grapes in Wisconsin, failed to grow grapes in Wisconsin, failed to grow grapes in San Diego, failed in the San Francisco side of the bay, and finally succeeded in Napa. And there, stories like this abound, and these are not just one season, but a long period. You have to let your stock grow, or your plants and trees and vines grow, or whatnot. What I want to do is, to some extent, play off some of the themes raised by the panelists in the morning session. There was considerable concern about invasive species, and I shall say a word or two about that. About comparative advantage, that's very important in understanding the effects and adaptation of California agriculture to global warming. David Zellerman emphasized the need for progressive leadership, and there are many other themes of this sort. Let me start by just giving you a sense of how adaptive agriculture has been in the past, and look at what historically was one of the most important crops in North America, wheat. If we took a snapshot, if we looked at a map in 1839, the center of North American wheat production would be someplace to the east of Columbus, Ohio. Most of the production would have been in Ohio, New York, and surrounding areas. If we take a snapshot 90 years later in 1829, before the advent of the Green Revolution, the biological revolution, and whatnot, the center of wheat production had moved northwest about 1,100 miles to central South Dakota. Well, this is the story of settlement in one crop in one direction that is common to all crops, including the crops that Californians produce. And as Dan Sumner said in the morning session, California was the second leading wheat producer in 1890 in the United States. Well, just what does that involve in terms of weather and adaptation? Well, we don't have any historical experiences comparable to what we're expecting in the future in terms of climate change. But we do have this historical experience in terms of climate differences. And if you ask farmers and leading scientists in 1839, could you grow wheat in South Dakota, they would have thought you were crazy. The varieties did not exist in the United States that would allow you to succeed in doing that. But South Dakota is just part of the story. Wheat had moved on the fringes up into, well into Alberta, Canada, and down into the region around Sonora, Mexico, Ciudad Obregón, and those areas, or was moving in those directions. Well, just in terms of climate, just how big are these moves? Just how massive are they? If you looked at the average rainfall, the median rainfall where wheat was grown in 1839, it was 100 centimeters, almost exactly 100 centimeters. What was it in the median rainfall where wheat was grown in 1929 was 50 centimeters. Farmers on average, not in Columbus obviously, but where wheat was grown, figured out how to grow wheat with half as much rainfall as what they had had 90 years earlier. On the fringes, it was much more extreme. And you had similar changes in temperature, both much colder environments and much hotter environments than anything that existed in North America for practical purposes in 1839. So as I say, these changes, now we just take them for granted, but many of your ancestors, or some of them, probably failed. People went hungry for a year. This was a tough road to hoe, and they had to figure this out, and it took time, and scientists played a role, but it was largely farmers themselves that did it. How big, let me give you an example of more on the extremes here. If you move, there is one study that I'm aware of, there may be more since I did this research, looking at, guessing at climate changes in specific locations. If you look at Alberta, Canada, over the next 100 years approximately, they're suggesting changes of 3 degrees centigrade and a 12% increase in precipitation. Moving wheat from Ohio to Alberta involved minus 7 degrees centigrade and minus 52 degrees, or excuse me, 52% in precipitation. If you went to Ciudad Obregón, the projection over the next 100 years is an increase of 2 degrees and an increase of 30% in precipitation. Moving from Ohio to Ciudad Obregón involved overcoming a climate challenge of an increase of 12 degrees centigrade and minus 65% in precipitation. So these were big, huge changes that farmers overcame. And you say, well, it was 90 years, whatever, it was gradual, it was this and that. But that's the kind of time period we're talking about. 100 years then was more or less like 100 years in the future. You find similar, not as greater changes in both the location and the conditions under which corn and cotton were grown. They were really quite significant, the other major staple crops of that period. Now, in the morning discussion on California, people emphasized overcoming shocks from new pests and more intensive pest environments. And on this, there are some examples. And again, many of you are aware of them in general, but phylloxera struck this state in about 1873. There was no cure. The cure was created in part by scientists at the University of California, elsewhere in the United States and in France. But that took a while coming. By 1915, 250,000 acres of vines had been torn up in California, and very few replanted on resistant rootstock that came out of the Midwest. They weren't always successful. I mean, this is a success, but look at the time period that it involved. Probably the best example in viticulture of a serious problem that wasn't solved and which is still with us was Pierce's disease. And Southern California was a thriving area of grape production, perhaps the largest producing region in the state at the time, and it was totally wiped out in the 1880s by Pierce's disease. It wasn't understood, and it was only much later that it became understood. So the shadow of the Matterhorn in Anaheim was once a vineyard. It is no more. If you look at tree crops, again, there's literally dozens of major examples, but I think the most interesting dealt with oranges, in which Cottony Cushenskill entered Southern California orange orchards in the 1870s, and the industry was doomed. It appeared that there was little or no hope for it. They tried arsenic sprays, they tried rubbing it with arsenic, they tried cyanide. There was a huge industry and people putting tents over trees and pumping cyanide in. Very nice for the environment. You know how it was solved? A USDA scientist looking for a solution observed ladybug beetle in southern Australia eating the scale. He imported, I think, 20 or so of these beetles. Within a few years, they had been tested and released to the general public. And in 1 year after the general release, orange exports from California tripled. So there's just a lot of examples of being hit hard by shocks and having to overcome them in a very creative way. And it doesn't mean that we'll be able to do that in the future, but we certainly, more often than not, had reasonable successes in the past. Now, the point that was made this morning about California being progressive on this and the leader on this, there's a lot of examples in which California was not so progressive and in some cases dead last. The one that comes to mind was in the eradication of bovine tuberculosis, a disease which by 1910 or so was probably killing about 10,000 people a year in the United States, mostly kids. So put that in the context of your spinach problems a few years ago, or whatever. It's just an enormously difficult story. For every kid killed, there were thousands, or certainly hundreds maimed probably. And the disease would have been killing if it had spread as it had before, somewhere in the neighborhood of 25 to 50,000 people a year by 1940. In actuality, nobody was getting it anew by 1940. I mean, you can count the cases on your hands. Why? A very aggressive government program, probably the greatest use of police power in the peacetime history of the United States, certainly before the Civil Rights Movement took place, in which veterinarians were sent on to every farm, and whether the farmers agreed or not, the cattle were tested in a laborious process, and if they reacted, they were slaughtered, they were culled. This was a national program exercised by a national agency with state participation. Which state was the last? California. California was the cesspool of the United States, and this gets on this issue. The farmers were knowingly poisoning people, farmers that were harboring this disease. Why? Because there were institutional inadequacies in the state constitution which did not allow for the payment of compensation. So where I see, to conclude, or at least this part, the issues being very, very difficult to predict are if we have property rights, if we have better property rights, particularly in water, and better markets, particularly in water, and you have individual solutions possible, the ability of California farmers to adapt is certainly among the best in the world, and they'll do fine. They may have problems, but on a comparative basis, they'll do fine. When you require collective action, and you require legislation to enforce this sort of things, you're going to have the kinds of problems that we see and saw in the past repeatedly. So I think I'm over my limit, but that's my attempt at a prediction.
Thanks, Alan. And there's a lot of potential things we could follow up on there, but please hold your questions, and we'll go through the other panelists. The next panelist is Marshall Burke. Marshall was just awarded his PhD from UC Berkeley. And Marshall is a prolific young agricultural economist. He's written a lot, especially on the effects of climate change on agriculture, on conflict, and on other social outcomes. And so I'm delighted to have Marshall here to speak.
Great. Thanks, Aaron. Thanks to Colin and the Giannini Foundation for what's a really important event. I was excited to be invited. So I'm going to start by trying to be a little more precise about what we actually mean by adaptation. So sort of on the most generic level, we can think of adaptation as any response that improves an outcome. So any kind of change in behavior that makes you better off relative to how you would have been had you not changed your behavior, right? So as you can see, this is going to mean a lot of different things to a lot of different people, right? People are different, interested in different types of outcomes, and so the specific type of outcome you're interested in is going to sort of determine what you mean by adaptation, how you understand adaptation to work. So this morning, and based on what Alan just said, we've heard a lot of potential ways in which farmers can adapt, in how they can change their behavior to improve outcomes as the climate changes. So some of the ways we think about that. So a farmer growing a particular crop can change the inputs he or she uses. She can use more or less irrigation water. You can use it at different times. The farmer can change varieties of a particular crop. The farmer can actually switch crops, so that would be an adaptation that's come up a lot. One that hasn't come up much is you could think about the purchase or investment in some sort of financial tool that helps mitigate climate-related risk. This could also be an adaptation. And depending on what your outcome is, another adaptation could be to get out of agriculture altogether. So if the outcome you care about is maximizing household income, it might be the case that in some parts of the country it gets so hot that it doesn't make sense to farm anymore, and it makes sense to get out of agriculture. Now, I'm not going to take a stand on whether that's the outcome. I'm not going to be arguing that California should be getting out of agriculture at all. I'm just saying that when you read the adaptation literature, this is something that comes up, getting out of agriculture altogether. Okay. So that's sort of how we understand adaptation broadly. So what will adaptation take? So I think it takes three things, at least at the individual level. So you're a farmer growing something. What is adaptation going to require? First, it's going to require that you actually recognize and believe that the climate is changing, right? And this sounds simple, but it's actually not so simple, right? So as Ben showed this morning, and as all the climate models tell us, sort of the most robust thing that we know about future climate change is that the global mean temperature is going to increase slowly over time, right? So all the climate models tell us that, but if you're on a particular farm, you know from year to year that the temperature moves around a lot. We have climate variability, right? Some years are hot, some years aren't. And so there's this hard signal extraction problem, right? You have to somehow pick out the slow-moving increase in temperature in the context of this very large, often very large increase or variability in temperature and precipitation from year to year, right? So recognition is not easy. Okay, so let's say you recognize and believe that climate is changing. The second thing is you also have to believe that an alternative course of action is going to make you better off, that some sort of change in behavior is warranted by this change in climate. And finally, you have to have options available to you, right? You actually have to be able to change your behavior. You have to have varieties you can switch to. You have to be able to access these varieties or invest in them. So those three things in general are I think, the things that are needed for adaptation, and it's not, I think it's clear that it's not automatic that those things will just happen on their own. Okay. So what do we know about adaptation in the U.S. so far? So Alan has worked and has written some really fascinating papers on sort of the longer-term profile, going back centuries, and how U.S. farmers in particular have adapted to really broad-scale differences in climate across the U.S. Most of my work has been on adaptation over the last few decades. And looking outside of California for a minute, what I think we know is, first, what was emphasized in Aaron's introduction and by the panel earlier, is that a lot of the crops we grow in the U.S. really don't like it hot, right? Max talked about this earlier, and as best we know, that happens for two reasons. Hot temperatures speed up crop development, so crops go through particular stages, and as you kind of turn up the thermostat, they go through these stages faster and faster, and the net result of that is typically to reduce yield. And the second main effect is through soil moisture, right? So we know if it's really hot out, you're going to evaporate more water out of the soil. The other thing is you cause the plant to use more water, and this extracts even more water out of the soil. So by the end of the year, you've taken a lot of moisture out of the soil, and you've increased the water stress of the plant, and that also tends to reduce yields. So the net effect of that, as Max pointed out, is what we see is as crops are exposed, in particular, to more and more extreme temperatures. So this is the temperature distribution. I'm doing right and left. So temperatures over here in the sort of the extreme part of the distribution, we see yields for these two reasons, development and soil moisture, drop off pretty dramatically, right? So we get a mean shift in the distribution, and you get more and more days spent out in this sort of extreme bin, right? So a good rule of thumb is for every 1 Celsius, about 1.8 Fahrenheit increase or shift in that distribution, you see a 10% decline in yields of the main crops we grow. So this is the main row crops, in the U.S. Midwest, things like corn, soy, and cotton. Okay, so 1 C increase, 10% decline in yields. That's a big number. So yields in the U.S. for corn have been growing at about 1% a year for the last 2 or 3 decades. So a 1 C increase in temperature is gonna knock down about a decade's worth of productivity growth for corn. So that's a big number. Okay. So we don't see these results just for yields. We also see them in broader aggregates. Max already mentioned this. Although the data are somewhat noisier, we see it in the farm profit data as well. And we also see it aggregated up at the country level. So we have a new paper, not out yet, new work showing that country-level economic productivity is also affected by this, negatively affected by this exposure to extreme temperatures. So our economies actually grow more slowly when it's really hot out. Okay, so that's impacts. In terms of adaptation, what have we seen? So one way to think about adaptation is to look at the sensitivity to extreme heat over time. And one way adaptation might show up is if the sensitivity had actually declined over time, right? So what we can do is we can look at farmers in the 1970s and see how they responded to really hot temperatures and compare them to the same farmers, farming 2 or 3 decades later and see if they've gotten better at responding to this extreme heat. And it turns out they haven't. If you do this in the U.S., so these are some of the most productive corn farmers in the world, it turns out they actually haven't gotten any better at dealing with these really hot temperatures. And if anything, they've gotten a little bit worse. So the difference between a good year and a bad year is actually larger in the last decade or so than it was 2 or 3 decades ago. So no obvious evidence of adaptation so far, sort of in at least in the last couple years, measured as this responsiveness to extreme temperature. Okay, so that's California that's the U.S. more broadly. What about California? So I'm actually a little bit more optimistic in California for a couple reasons. But first, the bad news. As we all know, California is the land of fruits and nuts. It's a bad joke. But these are perennial crops, right? So these are very different than the sort of annual crops that we study in the U.S. Midwest. And so this poses a couple challenges, many of which have already come up. Perennial crops are in the ground for a long time, obviously. So farmers are locking in production decisions that they're going to be stuck with or that will be expensive to change for many decades, right? Second, and Max mentioned this, in terms of the learning, it's actually very hard to learn about how some of these tree crops in particular respond to changes in climate. These things are in the ground for a long time. Temperature and precipitation in each month of the year could potentially matter compared to corn, where it's just growing for a few months out of the year, so you sort of know where to look. So understanding how these things respond to climate has been hard. That said, there are a few things that stand out, a few crops that stand out, where we think that climate might be detrimental for productivity. These are cherries. So cherries require a lot of chill hours. So this is hours spent between about a little above freezing and around 50 Fahrenheit. And so increases in temperature in California reduce the number of chill hours, and so this actually hurts cherry productivity. And that shows up in the data pretty clearly. Similarly, for high-quality wine, Max mentioned this as well. We know the quality of the premium wines in California actually declines under extreme heat exposure. So that's sort of the bad news. But the good news, and this has been mentioned already, is that California grows lots of crops, right? And as best we know, many of these other crops do not exhibit the same sensitivity to extreme temperature. So things like almonds, one of California's most important crops, as best we can tell from the data, are okay for about 1 to 2 to 3 C increase in temperatures. They just don't show, historically, they don't show that much sensitivity. So insofar that crop switching is an available adaptation, at least in the California context, you have lots of crops to which it might make sense to switch, and to which at least the science as we know it now suggests that there could be some benefits. The second thing, in my last 30 seconds here, it turns out that fruit and nut, these tree crops are actually going to benefit from CO2 fertilization. We don't know exactly how much, but these crops all use a particular type of photosynthesis called C3 photosynthesis, compared to crops like corn, which are C4 photosynthesis. So there's been a lot of experimental work in the past half decade or so to try to understand sort of what CO2 fertilization will mean for the yields of these crops. And the C3 crops, so the fruit and nut trees and things like rice and soy, actually seem to benefit perhaps substantially from increased CO2. So even if some of these things suffer a little bit by temperature, you're going to get this benefit from CO2, and that's not something you see in corn. So overall, I wouldn't call myself an optimist in terms of adaptation across the U.S. as a whole, but in California, I think our options actually look a little bit better. I think the big elephant, of course, in the room, which has been mentioned already, and why I'm excited for the next panel, is what happens with the water resources. So we're a little bit better on the temperature side in California than we might be elsewhere, but I think the water resources, since we depend so heavily on irrigation, are actually going to be the key part of this. So I'm as excited as you guys are to hear what the next panel has to say on that.
Thanks, Marshall. That's great. So our final panelist, another prolific young agricultural economist, Ariel Ortiz-Bobea, comes to us from Dominican Republic via France to Maryland, where he earned his PhD. and is now a fellow at the Resources for the Future in Washington, D.C. He will be moving soon to take a faculty position at Cornell University. So Ariel has worked extensively on adaptation of agriculture to climate change. So again, a good fit for this panel. And Ariel, please.
Okay, well, thank you for having me. I'm supposed to be the positive guy, so I'm going to be, so that's my role here. So first of all, thanks to Colin for inviting me and the Giannini Foundation. So this is, I think this is just a great event. So the way I'm going to try to go about this is, with any difficult question, I try to split things in little pieces in order to answer things. And so what I'll do is that the question that is asked, I'll split it into two. And the first one is, will farmers actually be able to adapt? So, so I'm not going to repeat any definition. Or are they actually able to change from one thing to the other? And then the second part is the other things that they're shifting to, not beneficial. So, are these other options not as bad as the current ones? So, in order to, I want to start with the second part, and so it gets back to what Max was saying before about the sensitivities, and we need the sensitivities. So, how sensitive are each sector, each crop, to climate? And so there's a lot of work on this. There's I don't know how many papers looking at the sensitivity, looking at how corn yields change at different temperature bands, how land prices are correlated with these temperatures, and just to throw my hat in the ring is that there's in terms of when you think about it, if we take one example, say corn yield. We say that the temperatures above 30 degrees are negatively associated with corn yield and other crop yields. So my question is, when is this heat happening within the growing season? So there's one timing issue is that for most field crops, there's the sensitivity to shocks is different throughout the growing season. For corn, it's right in the middle. So right in the middle, so corn flowering, say, in the Midwest is mostly around July, which is probably the hottest period. So when we're looking at only one channel and we find that these very hot periods, they actually happen in, the stress is actually happening in the most sensitive period of the year for corn. So, what if, the temperature rises? Well, maybe the growing season is longer. Maybe the farmers can actually plant a little bit earlier. Maybe they can choose a longer season cultivar to take advantage of the longer season. So, I have a paper that tries to look at that, and there's room. Actually, it's very, it's very sensitive. The window is sort of small. So, if you're able to move the sensitive period around, you actually can sort of escape some of these detrimental effects of extreme temperatures. So, now that being said, when we look at one channel only, there's so many channels that farmers can adapt through. So, just looking at one channel can only overestimate any effect that that we're considering. Another concern regarding what we economists are doing is that we're not dealing with experimental data. So the world, all the fields in the U.S. are not in a lab. We don't control everything that is going on. So temperature might be correlated. Extreme temperatures might be correlated with many other things like very low soil moisture. So you mentioned something about the moisture, and there's very complex interactions between temperature and moisture that we still don't really are able to model very well with econometric models. So, and in a very hot, in a very dry, very dry summers in the Midwest tend to be very hot. So if you measure one thing very well in your model and not the other, so if you don't measure water very well, then the temperature picks up the effect of the other thing. So, is it the temperature? Is it the moisture? Well, maybe if we're just forecasting, it doesn't really matter if you just care about, the forecasting ability. But when we're thinking about adaptation, it does matter. Is it the effect really of the temperature stress, or is it just a lack of water? So the adaptive solutions are different in both cases. Another thing, that just going back, so if we're just talking about one channel, we might be overestimating, but there's also been work on looking at many channels sort of lumped together. So instead of looking at crop yield, say, well, let's look at land values and say, how does land values in say the eastern part of the U.S. Change from places where it's very warm and compared to places that are cooler, especially in the summer. And the thing is that, well, we're using land values, and if you are a landowner close to a city or close to a very nice national park, that land value not necessarily is a good measure of agricultural productivity. So there are areas in the U.S. actually have a work in progress in this area, and where land values are extremely high. And when I say extremely high at the county level, it's higher than the best land in the Midwest. You go southern Appalachian Mountains. These are places where the temperatures are very low and you don't get over those 30 degrees Celsius. And these are areas that are marginal agricultural areas, but they're very expensive land. So there's some of the indicators that we're using to try to capture this might not necessarily be ideal. And so, when we are attributing, these effects on land values, we have to be careful with these other alternative sectors that might be influencing land values. So the other point I want to make is that, as was said before, there's so many mechanisms, and one of them is prices. So earlier in the previous panel, there was a good discussion by Dan Sumner about what is happening in the rest of the world. How are prices going to change of the products that we're producing? So that's a major mechanism, and a lot of the work that we do is actually we don't have like 30 person's team, so we have to sort of do what we can, and so we assume many times that prices remain fixed, but that's probably a major channel, impact channel, and so that's something also that needs to be considered. Another point is regarding innovation, and is that the innovation is not longer, you don't have to now be growing the grapes and by yourself, like trying out one state and then going to the other. Now, a lot of that innovation is on a farm. There's actually people who will make a living out of trying to find, where you can have a new variety that someone is willing to buy from you. So I think the ability to innovate has accelerated in a way that is unprecedented when you go back to the family farm early, before the first half of the 20th century. So I think it's a different ball game that we're playing regarding to that. So I think that's something also that David Zilberman was sort of alluding to. So 2 minutes. So now I try to tackle the first part of the question. Is like, will farmers be able to move from one thing to the other? Thing is that I don't doubt that people, that a farmer will do the best thing that is in their interest. So I don't doubt that part. So in terms of, when the springs are warmer in the Midwest, farmers take advantage of that. They plant a little bit earlier. They get the different cultivars. So even these changes from year to year, there's some adjustments, and so farmers do respond to these at least short-run changes. So we see that, but what I would be what I'm more worried about is if there are some rigidities that don't allow farmers to change from one thing to the other. So I think that this is where there's a very important role of policy here. So while I was So in that sense, not encouraging, poor use of resources, I think is just, well, it's easy to say, but when I was flying from into Sacramento, I was looking through the window, and I saw all this water, all the rice, and I'm like, well, it couldn't be that bad if water is put out, just in such a easy way that it can evaporate. So I don't want to create enemies with the rice industry here, but maybe that's the best thing they can do the short run. Okay, but there are rules that might be put in place that might not allow the best use of the resources that that farm, and water is a key resource. So I'm very curious to see, as you said, what the next panel is going to talk about. So, so these rigidities, might not allow this adjustment to happen. So this is something that was said before, and that's where the problems might be. Another thing that there's role for policy is for a proactive role of policy. So I think universities, extension services are just key for allowing these, next or these other opportunities to be available to farmers when the shift need to happen. So looking at these, in very dry years, what are the crops that do better? These are actually important ones because these, or the opposite, in very wet years, what are the crops and the farmers actually do better? So we can learn from these extremes and actually sort of think forward as a portfolio. Well, we don't know where the climate is going in California. That at least we have something we can know where to go in that direction. That's another point. And to finalize, one point that I wanted to raise is that there's path dependence in policies, and so it is important to sort of get things right early on, and be aware that you might be creating that these rigidities that don't allow farmers to go from one sector to the other might happen just because you postpone that decision, some decisions, a couple of decades. So.
Thank you. Thanks, Ariel. That was great, and there's a lot of things there I think that we want to pick up on. So while you're all sort of getting ready to ask your questions, I'm going to ask one myself. Ariel, you mentioned prices, and Alan, you mentioned comparative advantage. So I grew up on a farm in New Zealand. My dad had sheep, and one of them, stereotype, one of the more important things that the main thing that you pay attention to in deciding what to do, because there are options on the farm. You could devote more land to growing wheat in a particular year, or you could take on more sheep. And the first thing you do is you say, well, what are the likely economic returns to in this case, shifting more towards meat and away from wool. And so I wondered if maybe, perhaps all three of you, but if you could elaborate a little bit on how you think about comparative advantage and prices and how that might lead us to on the way forward.
Dan Sumner said something like this morning, but we're not the only area that's going to be hit. And in some crops, other major producers or competitors are going to get hit harder, presumably, and in maybe others, they're going to get hit less hard. There's a lot of historical examples of shocks hitting our competitors in which California farmers came out very well. Probably the best was a freeze in Florida oranges in 1894-5, and California catapulted up to the major orange producer in the nation for the next 20 years while Florida recovered, and Florida never got back seriously in the lemon market as a result of this. So this is the kind of thing, and with increased variability and droughts and so forth, you're apt to see this kind of thing. And it may be Brazil on one crop, or it may be China and grapes, or the other way around. But one thing that's pretty likely to be the case with our scientific infrastructure and the education of our farmers and so forth, we're apt to do as well or better to others in adjusting, except for in areas which really require serious collective action and changes in property rights, like on water and so forth. How long that will be tied up, I don't know, but that's I look forward to the next session also. But that's what I had in mind on comparative advantage. It's not just, we can suffer a downturn and love it if our competitors suffer twice as much of a downturn.
I concur, so I think just we have to know what the impacts are going to be elsewhere, in the long run, in the medium run. The long run, we're all dead. But it's a major channel, and in a lot of the analysis that that I do, for instance, is I assume that the prices are fixed, and it's a it's a working assumption, but it's probably just another elephant in the room is that what are the prices going to be?
I could jump in there. Even with fixed prices, I think that there are some difficult problems in California when you're thinking about this portfolio choice problem, especially if you're growing perennials that are going to be in the ground for 2 or 3 decades. So there are a few crops, I mean, some were mentioned earlier, I mentioned a couple, some have been mentioned here, that we do know something about in terms of how they respond to climate, and so sort of how their productivity might evolve over the next 2 to 3 decades. But California grows a lot of stuff, and many of these crops we have very, very poor understanding of how they respond to these changes in climate. So I think even aside the price point, this portfolio choice problem is just made hard by our lack of understanding of how some of these things respond to climate. So it's easy to get navel-gazing about the importance of research as a researcher, but this does seem like a place where further research on and I think Max mentioned this morning, further research on how the variety, this large variety of crops respond to warming or to changes in soil moisture would be really useful in terms of informing this portfolio of choice problem that farmers have.
Yeah, I think so. Just to add something, and there's a lot to learn, from years like this, where you can try to see, who did better, So these are experiments basically happening that, it's an opportunity to learn, from these extremes.
Greg Zlotnick with the San Luis Delta Mendota Water Authority. We serve agriculture south of the Delta through primarily the Central Valley Project. And I guess this is a question for Dr. Burke. One of the social outcomes you study, according to the bio, is conflict. I'm curious about, and this may lead into the next panel, and the prior panel might have something to say too, but the soil moisture issues, the temperature issues, you've all talked kind of about productivity and how that gets affected. The next panel is about water supply. Curious what your thoughts are about going forward when climate change with that temperature rise on water demand in the ag sector in terms of maintaining the same sort of level of productivity and the sector that we have in this state, where it's one of the top 10 in the state, I guess, and how that is going to impact down the road the demand for water to maintain agricultural productivity.
Yeah, that's a great question. So I'm going to punt on the California, the main sort of California water questions for the next panel. Those guys know, they've forgotten more about California water than I know. But I can touch briefly on the conflict issue, which might or might not be relevant here. So we have some research showing that various types of human conflict actually increase under hotter temperatures. So if you're interested in agriculture in particular, it's hard to know how much these results actually matter for California agriculture. But what we do find in the U.S. is various types of violent crime actually go up a lot under hotter temperatures. So things like aggravated assault. And I think this speaks to sort of a broader literature that Max alluded to about sort of we just become worse at doing things when it's really hot out. We make poor decisions. We're worse cognitively. We have lower test scores. All these things. We're less productive just individually. So in terms of these broader social outcomes and sort of the effect of climate on these, I mean, this could affect our ability to who knows, but it could affect our ability to sort of negotiate these sort of increasing water conflicts as we go forward in the future. Whether that's actually going to matter in California agriculture is hard to say, but we see this sort of conflict, in increasing conflict showing up elsewhere in the world sort of dramatically as temperatures go up. So that does not answer your water demand question. Like I said, I'm going to leave that to the experts in the next panel instead of saying something stupid.
Yeah, in the back.
One of the things that studies of technological change have shown that generally you need to have quite a significant increase in a critical variable in order to have change. For example, it's much warmer in Los Angeles than in New York, and in Los Angeles people are, or let's say Chicago, and you have much better Hollywood script in Chicago than in Hollywood and Chicago because it was too hot, people invented air conditions. Do we have any type of, because so to me really, how much can we learn from studies that really look about what happened to biological system in a little switch when we really don't realize what type of innovation. So how do you see the ability to take all these studies that are very valuable on one dimension and integrate it with studies that really look at some sort of processes? The reason that I ask here is because I didn't know anything about temperature, but I know that the highest yield of tomatoes in the Dead Sea, where average temperature is 45 Celsius a day. And I know that in some areas, when it's like people in the Midwest start to think about double cropping, and I think the double cropping will be a huge thing. We have a study recently that double cropping will be a huge thing that will really affect yield. And if you look at U.S. agriculture, altogether in the last several years, we overcome prices of corn are going down despite of biofuel. So how do we really incorporate this type of approach that really look very carefully at transient variable with some approach that really combine what Ellen is saying? Because if I look at what Ellen is saying and what Marshall is saying, it's like they live in different worlds. How we try to bring it together?
Please.
So, if I can say something, I think you need, I think that the hypothesis has to be an economic one. Like, in my view, you have to have a structure of the problem, and model the pieces of the problem. Like, what is the agent doing? So I don't know if it's trying to get at, what you're trying to get at, but I don't know if it's getting into like a reduced form structural debate.
I know the answer, but if I was a policymaker, I didn't know what to get out of it. Yes, one side said, man, we overcame everything.
Yeah.
The other person that said, a little change, everything will fall apart.
Yeah.
So how do we do some sort of approach that bring it together?
Well, I guess more research. Yeah, go on.
So, yeah, the broader sort of academic idea there, or one of them, is this idea of induced innovation. I think this is what you're talking about. So innovation occurs along some sort of scarce margin, or some sort of margin where, where innovation would be particularly profitable. So the story of corn in the U.S. over the last 20 to 30 years is interesting in this regard. So why has the sensitivity to heat not improved over time? So what's happened is breeders haven't been, and agronomists haven't been focused on extreme heat. What they've been focused on is breeding for the really, really good years. So what's happened is, if you compare the trajectory of yields in the hot years, it hasn't changed at all. But if you look at the trajectory of yields in sort of the cool and wet years, it's gone up sort of dramatically. So all of the yield increases have come through essentially breeding for these really, really good conditions, right? And that breeding effort has taken place over the last 2 to 3 decades. But you talk to some of these breeding companies now, and maybe there are folks in the room who work on this. Monsanto now actually has a large breeding program to deal with heat stress in particular, right? And so I think this is in the line with the sort of the induced innovation idea that you had. So it could be the case that they figured this out. It looks to be a hard problem biologically. It's controlled by many different traits, and so it's a hard breeding problem. But to the extent that innovation is induced around this heat stress problem, then the kind of responsiveness we've seen over the last 2 to 3 decades might be a poor guide to what it might look like in the future. And then if that's the case, then I think my world and Alan's world are not that different.
Thanks. This is Max. You can hear me from right here, but they can't. So this is a clarifying question for Alan, which is, if I put some words into your mouth here for a second.
Please do.
Oh, yeah, you can tell me that that's not the right thing to do. But what I heard was, we've overcome much bigger challenges than these changes that Max and the others were talking about before. I mean, tremendous changes in the temperature profiles and precipitation profiles of the environments that we've grown stuff in. The question I have is, we live in a world of 7-point-some billion people, I think, at this point, where the majority of calories come from 4 crops, right? Soy, corn, rice, and wheat, which are grown in large-scale monocultures, where, you have a couple of bad weather events in one point. You get Russia and Australia hit, and a little bit of China and northern U.S., and you've got huge impacts on global corn prices. So if I take your story and I try and tie this together about what the consequences of taking the time to figure out how to grow these crops in a new world under climate change is here. It to me, there's a worrisome dimension here. I have no doubt that we'll figure it out. But sort of 2, 3, 4 bad years, instead of having relatively small concentrated population affected by it, we're really talking about billions of people where the poorest of the poor are going to pay really high prices for these crops and are potentially going to be hungry. So to put this in economics terms, I wonder if the welfare implications of this, just by growing populations over time, relying on these concentrated growing regions here, whether the cost of waiting is maybe too high.
Well, I agree with you, and I don't think anything I said disagrees with you. The point that I would make is that when you look at what has happened in the past, people often look at today and assume this is the way it was 50 or 100 years ago. It's not the case. There's been a lot of evolution with and without the help of formal science in agricultural production locales and production systems and things of this sort. And that should give you some confidence that people are going to continue to evolve if you don't fix prices and do all kinds of really stupid things, which some countries have done more than others. That's what, it doesn't mean that we won't have future shocks or more regular future shocks. In terms of the corn or the wheat questions in terms of future breeding, I'm not a plant breeder. There may be somebody here, but I have talked to a lot of plant breeders, and what they tell me is, I think we can do this and we can grow something here. What they are not at all confident on is they can handle the wider fluctuations that are going to occur at any one locale. And so they may get a wheat that you can grow under some new set of conditions, but they can't, if they get an early freeze, it's not going to be like the spring wheats that were planted after the freezes, right? That's what I think they're concerned about. But don't underestimate how much adaptation will take place. It will be a huge amount.
To add something, I think that also adds. It's basically just the climate variability versus mean shifts. That I think the variability might be even just a bigger, a different kind of challenge for breeders and for the farmers themselves. So I think that's a.
We're looking at, you say a couple of years shock. We had a sort of a decade shock called the Dust Bowl, and this goes back to what you and David were saying this morning. And people literally moved, not from Mexico to California and Arizona, but from Arkansas and Oklahoma and places really hard hit, and they moved in droves. What are we going to do if large parts of Bangladesh and other areas are underwater? And millions of people, not hundreds of thousands of people, are all of a sudden on flight. You talk about, you're worried about conflict. Boy, there's a lot of potential for it, and it's hard for us to stay out of a lot of these issues. We have sensitive issues that.
Hi, I'm Joel Carlin with Western Milling. Just curious about crop yields and cropping patterns in the United States. There was an article in The Economist 2 years ago. They were saying that crop yields really haven't increased that much. It's actually been increased populations, corn populations and soybeans. The actual biomass of the plant has actually gotten smaller over the years because of environmental stress. Remember, Monsanto was touting 230 bushel per acre corn by the year 2030. We're nowhere close to that. And the USDA had a paper, they have a new weather yield, and they're actually saying that years of adverse yields are much more common than good yields because corn yields in particular have a nonlinear response where to rainfall you have less rainfall. The impact on yields is much greater than if you have good rainfall. So in our field, and I work with a lot of crop farmers in the Midwest, we've seen a lot of increased acreage of corn going up into the Dakotas and Kansas, and at the expense of like spring wheat and lentils and peas. And I was just curious about your thoughts on changing climate and cropping patterns in the United States and also here in California.
Who wants to jump in?
Well, just in terms of corn, so most of it is obviously from rain-fed in the Midwest, but in these other regions in the Great Plains, so actually a lot of it is just irrigated, and corn is a very sort of thirsty crop. So the water in that aquifer, in the Ogallala aquifer, is basically, you're basically mining the water. So in a way, you're accelerating the fact that you're just going to run out of it, of that resource. So I would be much more concerned about, that sort of, any policies that would encourage, that type of movement. Well, if the water was renewable, then it would be another matter. But so that's something that, I don't know if that answers.
Just to maybe clarify something on the yield point, I think it is the case that average yields have gone up on average about 1% a year for the last 2 to 3 decades in corn, specifically in corn. And I think, as I tried to mention before, I think that's mostly been due to the fact that yields in really good climatic years have gone through the roof. They've gotten really, really good. And the way that breeders have done that is increase the density, essentially. And I think this is what you're referring to. Essentially, how many plants are planted per square meter or whatever. So that's something like doubled over the last 2 to 3 decades or something. So the yield of a particular stock hasn't gone up. It's just that they've been planted more densely. So in a good year where you have a lot of moisture, this isn't a problem. The plants can grow really well. But you can imagine what happens in a bad year where you don't have enough moisture, right? You have, the density of the crops is so much higher that the crops are fighting over, the same amount of moisture, and so they're under a lot more stress. But that said, because in a good year, yields have gotten so much better, the average yield, so averaging across the good and the bad years, has gone up. And the other thing, I don't know if you guys could see the map that Governor Brown put up, but it turns out, for reasons that I think are starting to be understood, but aren't fully understood yet, parts of the U.S. Midwest have actually not warmed up really at all over the last 2 to 3 decades, right? So this is called the warming hole in the U.S. It's a big sort of question of scientific interest. So, and in some of these, our biggest corn-producing counties in Iowa and Illinois, temperatures have actually gone down slightly over the last 2 to 3 decades. So all the climate science suggests that that's not going to be the case in the future. But in many of our sort of main corn-producing areas, we've sort of gotten a break on climate change so far. So to the extent that climate change accelerates, I think that's really going to put downward pressure on this 1% a year increase.
On the back.
Hi, I'm Sarah Snyder with the Environmental Defense Fund, also a graduate of UC Davis Ag and Resource Economics Master's Program. Thank you all very much for coming today. I work with EDF in their agriculture and greenhouse gas mitigation team, and we've been looking at the U.S. and across the world at how farmers and producers can adapt and mitigate for greenhouse gases. So, Dr. Burke, you were talking about, what needs to happen for adaptation to happen, and I feel like for a lot of these, we've reached the point of number 3. There are options available, but what we're really missing is financial and other types of investment. So, where do you see investment coming that can help farmers who've made the decision or who know that they want to adapt or they want to mitigate? And where can that investment come from? We heard about other mitigation options in the last panel, but I really want to know where can those investment, if it's really expensive to change either a technology or the social costs to change, I think that we need to figure out where those points are.
Sure. Thanks. Yeah, great question. So I'm not sure that it's completely the case that we have all the technology in hand that we need. So in the U.S., I think it is the case that many of the large seed companies are working on breeding for heat tolerance now in particular. And I think it's the case that they're starting to release varieties that they claim are better suited to sort of these extreme or do better in these extreme heat years. But we don't really know whether or not that's the case yet. And this is in the U.S. where really large companies are throwing a lot of money at that. So this is to say nothing about smallholder maize farmers, corn farmers in sub-Saharan Africa, right? These guys do not have the technologies in hand right now that farmers in the U.S. do, nor do they have access to the capital that might help them afford these technologies were they available. So, I might take a little, if I understood your premise right, I might take a little bit of issue with the premise that we yeah, we might not. I think there's a lot more work and investment to do on the breeding side. In poor countries, this often happens through public sector money. So insofar as breeding effort, public sector breeding effort could be expanded there, I think this would have potentially huge benefits in the developing world.
Question over here on the left.
Hi, I'm Ben King. Actually, just the idea came up is because you talked about the basically average yields in good weather years, prices go up. I mean, productivity goes up. In bad weather years, you have more variability downside. But we just institutionalized a national crop insurance, a new farm bill. And actually, one way to promote innovation is to require, to qualify for crop insurance, is actually have a certain type of practice that'll be guaranteed by the crop insurance, because really the social cost for not adapting is greater. So this is a way to actually allocate that across. Just something to think about when you talk about these social things.
Yeah. Can I comment? So that's exactly right. And in the new farm bill, there's been a lot of money thrown at expanding the crop insurance programs. But I think this kind of broader question is what is the best way to invest in the adaptation here? Is crop insurance really a cheaper option than increased investment in breeding for these environments? And I don't actually know the answer to that, but it's not obvious that heavily subsidized crop insurance is going to be a better bet than spending more money on breeding for these new environments. It might be the case that the latter is a much cheaper way to adapt.
Yeah, if there are fundamental changes, we should be having social policies that encourage adaptation, not policies like crop insurance. For short run, fine, but if there's a fluctuation or something. But if it's a fundamental change, we don't want to be paying you to grow something you can't grow. Yeah, I wanted to make a point on this.
Because the social cost is actually borne by society.
So this can be a double-edged sword. That's all I want to say on that. But a really big issue that touches on much of what people are asking here is that there's a really wonderful book by Julian Olmstead at UC Davis in Agriculture and Resource Economics and his co-authors, Persistence Pays. And it looks at recent and projection of future trends in agricultural research and agricultural productivity growth. And what he sees is 2 points worthy of mention here. He sees one, he and his co-authors see a downward trend in the rate of growth, not a downward trend, but a downward trend in the rate of growth of agricultural productivity growth. And he emphasizes the relatively long-run payoff or period required between when research is initiated and when you actually start seeing payoffs from that research. So this is, to the extent we're worried about this sort of thing, it really pays to have competent researchers online right now, maybe working on something else that they can switch to and that they can adjust to. You just don't get good plant scientists, good veterinary researchers and so forth, in a year or two. It takes a long time, and particularly when you're all of a sudden increasing probably the responsibility of the developed world researchers for helping sustain production in the developed world. A final point on this is that when we measure the effects of this research, it's very easy to miss a large part of it. A good part of research goes into what we term ex post maintenance research. So there may be no increase in output resulting from the research that you observe, no increase that you observe, but you're preventing a decrease, something of that sort. And so you have to be really careful in evaluating these research projects, and if you're just not seeing much increase, maybe not throw the baby out with the bath. It could be preventing a big downturn. Anyway, I recommend that book to anyone who's serious in this area.
Just to briefly say that when you subsidize something, you sort of encourage a behavior, and you might be having farmers incurring more risky behavior by just subsidizing crop insurance. And if you see where most of the payments for corn, for the crop insurance payments, they're mostly in the Great Plains, and that's probably maybe a place where I don't know. I don't think it might be the best thing to grow, but it is definitely what they're growing. And if it is, it's because it makes sense for the farmer, because there's they're getting an incentive to do it. So,
Steve.
Thanks. Steve Sexton, NC State. To what extent may these shifts in mean temperatures lengthen growing seasons sufficiently to allow double cropping, which could then mitigate these yield losses? Does anyone on the panel have a sense of that?
I don't exactly about not. That's something that it's actually in my research list. But what I've seen is only for corn. If the longer season, if we're just talking about a meat change, the ability to change to plant earlier, say a couple, don't remember exactly. It's like maybe 2 to 3 weeks earlier. You can actually reduce about a half or to 2/3 of the damages by just moving that sensitive period earlier on. Now, it's all about can they actually move earlier the growing season, and how reliable is that move going to be? Because how is their spring going to look? Is it going to be too wet? Can the tractors go into the field? That's something that I'm also working on to try to see where these constraints are on the growing season. But the variability is also a major factor, because maybe it's warm out and you're like, well, should I go plant? It's not that clear because it might just freeze again. So that's a challenging cycle for row cropping. I don't know.
I think that's right. The corn growing season now is so they're different varietals, right? And so there'd have to be some breeding effort to breed. If you wanted to double crop corn, say in the U.S., the length of the growing season would have to come down significantly relative to sort of the average varietal growing season length now, which is something like 120 or 150 days. So multiply that by 2, and you've eaten up most of the year, and the ground's frozen a lot of that time in Iowa. So you wouldn't actually plant corn. You'd plant something else.
Yeah, it might be something else. Maybe soybean. I don't know. Yeah, soybean.
Sure. Sure. Yeah.
Reza Badavi, Air Resources Board. I guess much of your discussion limited to the crop production. What can be done after production? Preservation, transportation, processing, waste reduction, in terms of the adulting.
I haven't done any work on that, but you can think about even the quality. If the fall starts getting too wet, for instance, I don't know. That's just a speculation. Then you might have problems just for drying grains. So that might get into the quality issues. I don't know.
I also haven't worked on this much in the U.S. I've worked on it in developing countries some, and we actually see that the post-harvest losses. So you see these estimates that sort of the post-harvest losses and wastage add up to a lot of sort of extra losses. So we're just essentially throwing away productivity. So as best we can tell, in at least the East African setting, those numbers aren't quite as big as what people had suspected, but I suspect they're still really large. But I don't know about the specific sort of policy options in terms of reducing.
Because it depends if it's climate related, So it's transportation, So if those elements get disrupted, then you get into trouble. But if they're not, it's like how sensitive they are to climate, these other sectors. And so far we've been dealing with the living part of the cycle, So the crops, the livestock, and not necessarily all these value chains.
Hi, Andrew Stevens, UC Berkeley. So far, this conversation on sort of the U.S. Crop footprint has been on the dimensions of temperature and precipitation mostly. I'm interested if any of you have any insights on soil type, soil quality, or nutrition availability, and how some of these other dimensions might complicate either the historical story or the future story, and what are some of the other things we should be thinking about, whether that's nitrogen fertilizer or rotating with soybeans, or whether the soil is even usable for some of these crops.
In terms of In terms of soil quality, if you look at a map, the USDA puts out of an 8-level soil quality scale. If you look at how good the land is across the U.S., you immediately see the Midwest, the Corn Belt, and the Cotton Belt, and the Mississippi Delta. So, we always talk also about the ability to shift. If the climate, the Corn Belt is going to move north. Well, there's actually an additional restriction, is that the soil might not necessarily be the best for that crop. So I think that's an additional factor that I know that we haven't given enough attention in all of this, because there's interactions between the climate and the soil in terms of they're not completely separable. So I think that's a major factor. Now, in terms of nutrients, I have no clue. But
I think that's right. I'm no expert on this either, but I think it's the case that, especially if you look in the Americas and places that have been populated for a while, you don't see a lot of places where the soil is good that aren't being farmed and where you don't have forests, right? So to the extent where there are areas that aren't farmed with good soils, they have trees on them, and so sort of expanding acreage into these areas are going to involve some other costs that we also worry about on the climate side. I think that's generically true in the Americas. I don't know if it's completely true globally, but.
Well, I would make just a couple of general points, and that's to the extent that we're seeing more variation around in different parts of the world, not just here in rainfall and more droughts and so forth. You can envision at least scenarios where there's more erosion, where there's loss of soil nutrients. You could also envision as very poor countries get hit hard, you could see interest rates going up and people mining the soil more as they're trying to get a crop to survive the year, things of that sort. So you could see deterioration in soil quality as a general point under those kinds of conditions.
Yeah, thank you. Rick Bettis with the Sierra Club Climate Committee and Energy Committee. Well, you mostly answered my question with the previous question, but I was concerned about if the research doesn't yield a solution, the breeding research that you're doing in the lab and all. When it comes to relocation, you talked about the soils problems, but what about the political and the conflict problems if you start thinking about significant relocation of cropping areas?
So, at least in the U.S., the percentage of people involved in farming is not that high. So even if you think about sort of a mass relocation of existing U.S. farmers, it's not going to be a huge percent of the population. So, maybe there are some stories you could tell about how that might create some conflicts. And we've already seen, actually, there are a couple papers that show in the counties that have warmed up the most over the last sort of 2 to 3 decades, there has been some small amount of out-migration, people essentially selling their farms and going to do something else. So I don't think the conflict story is one we're going to worry about as much in the U.S., but the Bangladesh, Alan brought up the Bangladesh case earlier, and I think there's some suggestive work in Africa that in other settings where you have large percentages of the population who depend on agriculture for their livelihoods, if these livelihoods are disturbed substantially, then you could see various types of conflict. They might be migration related, they might not be migration related. But in work we've done, these sort of climate-related conflicts show up across a variety of settings, and we don't actually know if it's migration or if something else, or what sort of the intervening variable is that links changes in climate, in particular increases in extreme heat, to these conflict outcomes. But they show up again and again in the data. So this personally is something that keeps me up at night. And so something I think we want to know a lot more about. I don't think it's going to be a huge problem for California agriculture, but it might be problems elsewhere.
Where I think I don't know quite what you mean by conflict, but controversy and conflict, something like this. We're likely to have new pathogens, maybe an increase in pathogens if the old ones don't go away, and that's going to very likely lead to the demands, at least of some groups, for more government intervention and collective action to control these pathogens, diseases, insects, whatnot. If all of us are farmers and you don't do anything and the rest of us do something, you just continually reinfect us, we're going to demand that you get regulated. And we have those kinds of regulations in effect now on all sorts of things, but if they're pushed out to new frontiers, there will almost surely be a lot of controversy and conflict on those. I don't know what would not be covered by today's infrastructure, but every time there's something new, people get very upset about it. And this, by the way, is going to be international. There will be, calls for increased controls to prevent imports and cross-border movement of foods, plant stocks, animals, things of that sort.
Yeah, not just that people don't like change. So every time there's something new, comes about, there's uncertainty about something, then you're not going to have fans. And also, just to point out that the crops can move without people moving, also because just people grow something else. So you might. So in the U.S., well, it might not be, but in some other countries, you might have these big issues because, well, maybe there's not something else to move to. So I don't worry as much for the U.S. as I would, for sub-Saharan Africa or other regions in the world.
I think this brings up an interesting potential conflict where we would say, to the extent that we're more likely to see droughts or higher volatility in some areas but not others, that economic trade can mitigate that to a great extent. If there's one region that gets hit hard by a shock one year, it's a different region next year, it's a different region thereafter, and with trade, you can smooth that out. To the extent that you have pests or other increased pest pressures that force or compel people to want to restrict trade, then those two objectives are fighting against each other. Question?
Hi, Adam Coden with the California Climate and Agriculture Network. We've been talking about agricultural adaptation sort of across the sector. In California, obviously, we have a lot of very small farms and comparatively fewer very large farms. I'm wondering if scale of operation plays a role at all in the ability to innovate and adapt, and if you have any thoughts on that.
I'd be interested to see the number of farms after this year in California and which farmers actually went out of business. So that would be we can actually check that. So to see who's more resilient to these shocks. So that would be maybe something to look at.
I agree. It's a fascinating question, and I have nothing to add other than it's a really good question. I don't know if Alan has something.
Yeah, I do. I think, at least historically, if you go to very small farms and very poor farms, they didn't adapt very well to past shocks of past diseases, weather problems. Now, I don't know. We're not talking about, southern sharecroppers here in California when we talk about small farms, but I think this would probably be true in the third world countries also. The very small just don't do very well. David, do you have a?
Well, I think that what happened is that as the public sector support for agriculture is declining, you have more large farms. But altogether, if you have the system that there is a shared supply of public goods, I think the system survives the bigger droughts. So I think that the structure wouldn't change. I think in developing countries, that's where you will see a lot of problems. My main worry is that some of the support that you got from the university in the past is eroding.
We're getting close to the end of our time, so we have about 3 minutes left. So, we've talked about a lot of different potential routes for adaptation, things at the management level, from changing planting times, fertilizer use, et cetera. We've talked about potentially changing crop choices, We've talked about the potential role for research, new technology development, whether through public research or through private investment, the role of infrastructure, the role of trade, other things we didn't talk about but could have, like the potential for other climate change policies that impose higher costs on agriculture and maybe prevent adaptation, all kinds of things that we could have talked about. So what I'd like to do maybe is for each of our panelists to take a minute and say if you had one talking point that you would like to get across to the ruler of the world about agriculture and adaptation, what would you say?
I can start. I can jump in.
Ariel goes.
So I would say don't pick winners. Don't pick a winner because you might get the wrong winner. So don't pick winners and be proactive about having other options that farmers can pick, and that's a tricky balance because how do you invest in public research without picking where the money's going to go? So
one of mine would be just invest in understanding. I mean, I think we've learned a lot about how adaptation might work and how some crops might respond, but there's still so much we need to know to help inform farmers about these portfolio choice problems, which will induce the sorts of innovations we want from companies. So I think research has shown in other settings, as Alan mentioned, and particularly in this adaptation setting, these investments in increasing our understanding of how agriculture responds to climate, I think, could yield huge dividends.
Alan,
the typical call for more money for research, but embarrassing.
I probably wouldn't give the same advice in every country as I would here, but here, many of the questions, at least I sense that people would love to know what's going to happen on my land or for my type of industry in California agriculture. And the answers are, the models are just so difficult, and we really don't know except for maybe in general directions. And so this goes to your points, and that's farmers are going to respond if you don't lock them in with too much crop insurance, with fixing prices, with guarantees here and that. And if you don't let them respond or even encourage them to respond, the problem is the magnitude of the cost of not doing so will grow and grow and grow. So I think my advice would be there will be changes. Trust farmers to respond, probably increase research and help markets become better greased with lower transaction costs and other things, which we're pretty good at in this country. And of course, the big issues are water in California, and I'm not going to comment on that because we have a panel coming up, but that's where I would go.
Thank you, and thanks very much to all three of the panelists.
Good.